Hello everyone. Today we are going to review solving by substitution. So these notes are the exact same notes that we went over in class, but it's been a while, so I'm just trying to put this in a video. So if you want to hear it again, you can look at these examples. You have the steps listed. You can either copy the steps into your notebook or look at them from the video. But with substitution, our goal is to reduce the system to one equation that has only one variable. Because when there's one variable, we can go through and solve for that variable. So first, we are going to isolate an equation for one variable and substitute it into the other equation. So when I mean isolate, I mean I'm looking to get y equals, or I'm trying to get x equals, like I have in these two. So for both of these examples, I don't have to do any work to isolate the equation. All I have to do is substitute it into the other equation. So let's look at this example. So if my y is equal to 3x, I'm going to take this 3x and put it in for this y. So I will have 2x. And instead of writing y, I'm going to write what y is equal to, and y is equal to 3x. So I replace that y with 3x, and then everything else stays the same. So I have is equal to 20. In step 2, I'm solving for one variable. So now I'm going to go through and think about, well, what do I need to do in order to solve for x? Well, I have like terms, so I can combine my like terms, and then I can divide by 5 to get my x is equal to 4. With systems of equations, in my problem, I have two variables. I have x's and y's. So I'm not done until I solve for both variables. And so in order to find the y value, I can pick either equation. And I'm actually going to pick the second equation because it's a lot easier to work with. So if I have y is equal to 3x, I'm going to take this 4, and I'm going to put it right in there for x. So I have y is equal to 3 times 4, and then my y is equal to 12. So my final answer for this problem is x is equal to 4 and y is equal to 12. All right, let's look at the next example. So in this problem, I have x plus 3y is equal to 15, and x is equal to 2y plus 5. So looking back at step 1, isolate an equation for one variable and substitute it into the other equation. So I actually don't need to isolate because I already have an x equals. You don't always have to isolate x. It's okay for you to isolate y or x. So now what I'm going to do is I'm going to take this 2y plus 5, I'm going to plug it in for my x right there. So I'm replacing x with 2y plus 5, and then everything else in my equation stays the same. I know I've done this step, well, maybe I don't know if I've done it right. I know I've done this step wrong if I still have two variables. So if you still have two variables at this step, try substituting again. Looking at step 2, I'm going to solve for one variable. So I have 2y and 3y, so I can combine my like terms. I can subtract my 5, so I have 5y is equal to 10. And then when I divide by 5 on both sides, I get y is equal to 2. I'm not done until I find both solutions, so now I'm going to go back and solve for x. And I think it's easier if you have an x equals equation, that's the one you plug it into. So I'm going to use 2y plus 5, but you can still find the correct answer if you plug it into the top equation. It's just a few more steps. So now what I'm going to do is I'm going to plug in 2 for y. So I have 2 times 2 plus 5, so my x is equal to 4 plus 5, my x is equal to 9. And now I'm going to do a check on this one. So I want to know, did I solve this correctly? And it's correct if x equals 9 and y equals 2 makes both equations correct. So I'm going to plug it into the first equation. So if I plug it in, x plus 3y is equal to 15. So I have 9 plus 3 times 2. That's 9 plus 6 is equal to 15. And since those values are equal, that one's looking good. And so I have x plus 2y is equal to 5. Oh, nope. I got that equation wrong. Let's go back. And it is x is equal to 2y plus 5. And so my 9 is equal to 2 times 2 plus 5. 9 is equal to 4 plus 5, and that is correct. So I know that answer is correct because it makes both equations true.